Have you ever wondered why, about 700 million years ago, our Earth transformed into a gigantic snowball? Picture this, a world encased in ice, from the tallest mountains to the deepest depths of the oceans. Scientists call this the snowball Earth hypothesis, a theory that has intrigued and puzzled the scientific community for years. It's a scenario that seems more fitting for a science fiction novel than a chapter in our planet's history. Imagine, our blue and green Earth, all of it, transformed into a bright white sphere suspended in the void of space. This wasn't just a little ice age, no, this was a deep freeze, an extreme event that extended even to the tropics, a complete global winter that lasted for millions of years. Now, isn't that something? It's a mystery that has left scientists with more questions than answers. That was a chilly chapter in Earth's history, wasn't it? But what caused this deep freeze? For years, scientists have been scratching their heads over what might have caused this extreme shift in climate. Theories abounded, each more fascinating than the last. Let's dive into some of these hypotheses, shall we? One of the most prevalent theories was that a drastic drop in greenhouse gases could have led to this global cooling event. Now, greenhouse gases like carbon dioxide and methane create a sort of thermal blanket around our planet. They trap heat from the sun and keep our world at a comfortable temperature. But if these gases were to suddenly drop, that cozy blanket would thin out, and Earth would be exposed to the cold harshness of space. It's a plausible theory, isn't it? Another fascinating hypothesis involves volcanic activities. You see, when volcanoes erupt, they spew out a massive amount of particles into the atmosphere. These particles can block sunlight and cause temperatures to plummet. Some scientists postulated that a series of intense volcanic eruptions could have created a thick layer of particles in the atmosphere, dimming the sun and turning the Earth into a giant snowball. Then there's the theory about Earth's tilt. Our planet doesn't sit straight up and down, but rather it leans on its axis. This tilt is responsible for our seasons. Some scientists speculated that a change in this tilt might have thrown our climate system out of balance, leading to the Big Freeze. While these theories made sense, none could fully explain the magnitude of the freeze. Until recently, in a groundbreaking study, scientists have finally pieced together the puzzle of Earth's Big Freeze. The mystery that has baffled minds for centuries is now a bit clearer thanks to an innovative blend of geological evidence and advanced climate models. The team of researchers embarked on a journey through time, studying ancient rock formations and ice cores. What they discovered was quite remarkable. It turns out, around 700 million years ago, our continents were not scattered across the globe as they are today. Instead, they were clumped together, snuggled up near the equator. This unique continental configuration had a profound impact on the planet's weathering processes. You see, weathering typically acts as Earth's thermostat. It's a natural process where rocks absorb carbon dioxide from the atmosphere, effectively cooling the planet. But with the continents cuddling at the equator, weathering rates dropped drastically. And what happens when the Earth's thermostat goes on the fritz? Carbon dioxide, a greenhouse gas, began to accumulate in the atmosphere. This triggered a massive global cooling effect, chilling the Earth to its core, and setting the stage for the Big Freeze. This discovery is a testament to the intricate web of factors that govern our planet's climate. It's a stark reminder of how even seemingly minor shifts can have far-reaching consequences, transforming a warm, hospitable Earth into a frigid snowball. So it seems the arrangement of our continents played a significant role in turning Earth into a snowball. But if Earth froze over, how did it thaw out, and why aren't we living in a snowball right now? This question leads us to the unfreeze. As it turns out, Earth had its own natural defrosting mechanism, volcanic activity. Despite the icy conditions, volcanoes continued to erupt beneath the ice. These eruptions spewed out greenhouse gases, mainly carbon dioxide. Over hundreds of thousands of years, these gases built up in the atmosphere. This accumulation of greenhouse gases created a warming effect, just like a blanket around our planet. As this process continued, the ice began to melt, and the climate started to warm up again. These findings are significant for several reasons. They not only give us insight into our planet's climatic past, but also provide valuable lessons for the future. Understanding these natural processes could inform our strategies to tackle modern-day climate challenges. So next time you're feeling chilly, just remember, it could always be a little cooler, like Snowball Earth cooler.